For a larger electrical system, we have to consider many other things to properly ground and bond this electrical system. We will give a few examples of components and systems to hopefully clarify any confusion that may arise. Let's talk about two important terms, service entrance and separately derived systems. Simply put, think of service entrance as the electrical equipment fed from the utility source. This may include a transformer, a service disconnect, or other protective devices. There are very specific rules in the National Electrical Code for service entrance equipment and grounding. Think of a separately derived system as a point downstream of the service entrance equipment where electrical isolation creates a new source. Usually, this is a new transformer connection or perhaps a generator. In either case, a new grounding and bonding scheme is required for this separately derived system. Here's an example of a separately derived system with delta Y three-phase transformers. Here is the grounding electrode conductor, and the main bonding jumper. This establishes the grounded conductor that we talked about in the previous section. Let's show you how a residential service and a load center are typically grounded and bonded. A residential system is a solidly grounded system with two hots and a grounded neutral conductor, which is a single wire. This allows the utility to ground the transformer and you to ground your main load center without dividing the current going back to the source because there's only one wire. NEC section 250.20b tells us that all premises wiring systems shall be grounded when the voltage to ground on the ungrounded conductors doesn't exceed 150 volts. So now let's look at a commercial power distribution system. As you get outside the residential world, you have more options based upon the applications. For example, data centers and other systems that demand a higher service continuity may opt to use high resistance grounded systems as opposed to solidly grounded systems. Many commercial and light industrial systems will be solidly grounded. Let's show you how a pad-mounted transformer might be grounded and bonded, and how the indoor switchboard might be grounded and bonded for a solidly grounded commercial power distribution system. Finally, for larger systems using unit substations and switchgear, here's how the grounding and bonding is done for those systems. For larger systems like the pad-mounted transformer or the switchgear, if the utility owns the transformer, we would see the neutral to ground bonding jumper installed inside our switchboard or switchgear, and we would bring the grounding electrode conductor into that service equipment. That is why it is clearly marked as service entrance equipment or suitable for use as service entrance equipment because it has the capability to bond the neutral to conductors inside that equipment. The transformer is a very important piece of a power system puzzle because it establishes the voltage levels and that neutral point on the power distribution system. Depending upon the winding type, the transformer establishes the configuration that you will have to use. For example, the transformer connection may be a typical one like the delta Y, or maybe more unusual like a delta zigzag or a high leg delta. Well-established methods for grounding and bonding these transformers can be found in our consulting application guide. Now, everything that we have just discussed around power system grounding is separate from the bonding discussion that we had because regardless of the grounding method for the power distribution system, the equipment grounding doesn't change and bonding is still critical and required. The difference is that the grounded conductor and the grounding conductor must be insulated from each other outside of one point in the power distribution system where they're bonded. Any subpanel in a power system must not have a connection from the grounded conductor, which is typically the neutral, to ground. Remember too, this is only relevant if you have a grounded conductor because with a delta high resistance system or an ungrounded system, you're not going to have that grounded conductor.